2,000 years ago, there were a group of Greek philosophers called the Pythagoreans. They worked out the laws of harmony on a violin string. They realized if you take a violin string and you looked at the resonance of it, the resonances corresponded to integers, and they were marveled that music could be explained in terms of a vibrating string. And they then said that perhaps the universe could be explained by the laws of harmony. We now believe that we can revive the thoughts of the early Pythagoreans and explain the universe through vibrating superstrings. Some people say, you know, Professor, when I see a chair, I know what a chair is, I can feel a chair, touch a chair, but you physicists, when you talk about strings, what the hell is that? Well, yes, we are all agreed what a chair is. The chair has 4 legs and it's made out of wood or metal and it has atoms inside. However, what makes up the atoms? Well, if you look inside the atoms, there's electrons whizzing around the nucleus. Well, what are they made out of? You can smash them apart. Inside the nucleus, there are protons and neutrons. Well, we've smashed them. What's inside neutrons and protons? Well, we think there's something called quarks. Well, does it stop there? Does it stop at the quarks? We now believe that if you had a microscope and could look at the quarks themselves, you would realize that they are nothing but little loops. Little tiny vibrating loops vibrating at a certain mode. And if you whacked it hard enough, it would turn into an electron. And if you whacked it hard enough again, it would turn into light. So in other words, we're talking about an elemental uber form of matter. One object, such that if it simply vibrates in a different way, it can create all the things we see around us. Therefore, instead of having this whole zoo of subatomic particles, you just have the string. However, this theory had a very big defect, a defect so great that it led to the near death of this theory. This theory predicts that the universe exists in 10-dimensional hyperspace. And I remember the very instant that was worked out in the early 70s. At that point, the cynics said, "This is Star Trek. Beam me up, Scotty." I mean, you want us to believe that there are hidden dimensions out there? Just like the mystics used to talk about ghosts and demons in higher dimensional space. We were laughed at. It was very hard for us physicists to get jobs. People were saying, this is science fiction. This is not physics. We're talking about a theory of everything based on 10-dimensional hyperspace? Come on. Well, we had the last laugh, because now string theory is taught in all the major universities. All the Ivy League schools are scrambling to hire string theorists. And we now believe that the mind of God is music resonating through 10-dimensional hyperspace.
In the 1980s, the idea caught on, and people started jumping on the string bandwagon.
Well, the fact that suddenly all these other people were working in the field had its advantages and its disadvantages. It was wonderful to see how rapidly the subject could develop now because so many people were working on it.
One of the great attractions of strings is their versatility. Just as the strings on a cello can vibrate at different frequencies, making all the individual musical notes, in the same way, the tiny strings of string theory vibrate and dance in different patterns, creating all the fundamental particles of nature. If this view is right, then put them all together and we get the grand and beautiful symphony that is our universe. What's really exciting about this is that it offers an amazing possibility. If we could only master the rhythms of strings, then we'd stand a good chance of explaining all the matter and all the forces of nature. From the tiniest subatomic particles to the galaxies of outer space. This is the potential of string theory, to be a unified theory of everything. But at first sight, in our enthusiasm for this idea, we seem to have gone too far. Because we didn't produce just one string theory, or even two. We somehow managed to come up with 5.
5 different string theories, each competing for the title of the theory of everything.
And if there's going to be the fundamental theory of nature, there ought to be one of them.
I suppose a number of string theorists thought, oh, that's fantastic, that's wonderful, and maybe one of these will end up being the right theory of the world. And yet there must have been a little nagging voice at the back of their head that said, well, why are there 5?
With 5 competing players, the stage of string theory was looking a little crowded. The 5 theories had many things in common. For example, they all involved vibrating strings, but their mathematical details appeared to be quite different. Frankly, it was embarrassing. How could this unified theory of everything come in 5 different flavors? This was a case where more was definitely less. But then, something remarkable happened. This is Ed Witten. He's widely regarded as one of the world's greatest living physicists, perhaps even Einstein's successor.
Ed Witten is a very special person in the field. He clearly has a grasp, particularly of the underlying mathematical principles, which is far greater than most other people.
Well, you know, we all think we're very smart, and he's so much smarter than the rest of us.
In 1995, string theorists from all over the world gathered at the University of Southern California for their annual conference. Ed Witten showed up at Strings 95 and rocked their world.
I was really trying to think of something that would be significant for the occasion. And actually, since 5 string theories was too many, I thought I would try to get rid of some of them.
To solve the problem, Witten constructed a spectacular new way of looking at string theory.
Ed announced that he had thought about it, and moreover, he had solved it. He was going to tell us the solution to every string theory in every dimension, which was an enormous claim. But coming from Ed, it was not so surprising.
The atmosphere was electric because all of a sudden, string theory, which had been going through kind of doldrums, was given an incredible boost, a shot in the arm.
Ed Witten gave his famous lecture, and he said a couple of words that got me interested. And for the rest of the lecture, I got hooked up on the first few words that he said and completely missed the point of his lecture.
I remember I had to give the talk after him, and I was kind of embarrassed too.
Ed Witten just blew everybody away.
Ed Witten blew everybody away because he provided a completely new perspective on string theory. From this point of view, we could see that there weren't really 5 different theories. Like reflections in a wall of mirrors, what we thought were 5 theories turned out to be just 5 different ways of looking at the same thing. String theory was unified at last. Witten's work sparked a breakthrough so revolutionary that it was given its own name, M theory, although no one really knows what the M stands for.
What is the M for? M theory.
M theory.
M theory. M theory.
M theory.
M theory is a theory.
I don't actually know what the M stands for.
Well, the M has
I've heard many descriptions.
Mystery theory, magic theory,
It's the mother theory.
matrix theory.
Monstrous theory. I don't know what Ed meant.
M stands for magic, mystery, or matrix, according to taste.
I suspect that the M is an upside-down W for Witten.
Some cynics have occasionally suggested that M may also stand for murky, because our level of understanding of the theory is in fact so primitive. Maybe I shouldn't have told you that one.
Whatever the name, it was a bombshell. Suddenly, everything was different.
There was a lot of panic, if you like, realizing that big things were happening and all of us not wanting to get left behind in this new revolution of string theory.
After Witten's talk, there was renewed hope that this one theory could be the theory to explain everything in the universe. But there was also a price to pay. Before M theory, strings seemed to operate in a world with 10 dimensions. These included one dimension of time, the 3 familiar space dimensions, as well as 6 extra dimensions, curled up so tiny that they're completely invisible.
Well, we think these extra dimensions exist because they come out of the equations of string theory. Strings need to move in more than 3 dimensions. And that was a shock to everybody, but then we learned to live with it.
But M theory would go even further, demanding yet another spatial dimension, bringing the grand total to 11 dimensions.
We know that there have to be 11 dimensions for this theory to make sense. So there must be 11 dimensions. We only see 3 plus 1 of them. How is that possible?
For most of us, it's virtually impossible to picture the extra higher dimensions. I can't. And it's not surprising. Our brains evolved sensing just the 3 spatial dimensions of everyday experience. So, how can we get a feel for them? One way is to go to the movies. We're all familiar with the real world having 3 spatial dimensions. That is, anywhere I go, I can move left, right, back, forth, or up, down. But in the movies, things are a bit different. Even though the characters on a movie screen look 3-dimensional, they actually are stuck in just 2 dimensions. There is no back, forth on a movie screen. That's just an optical illusion. To really move in the back, forth dimension, I'd have to step out of the screen. And sometimes moving into a higher dimension can be a useful thing to do. So, dimensions all have to do with the independent directions in which you can move. They're sometimes called degrees of freedom. The more dimensions or degrees of freedom you have, the more you can do. That's right. And if there really are 11 dimensions, then strings can do a lot more too.
People found fairly soon that there were objects that lived in these theories, which weren't just strings, but were larger than that. They actually looked like membranes or surfaces.
The extra dimension Witten added allows a string to stretch into something like a membrane, or a brain for short. A brain could be 3-dimensional, or even more. And with enough energy, a brain could grow to an enormous size. Perhaps even as large as a universe. This was a revolution in string theory. Our picture of space has gone through a remarkable transformation. Back in Newton's time, space was just the container. It didn't do anything at all. Then through Einstein, space begins to affect how objects move. Then with Casimir, literally objects can be pushed by the activity even in empty space. And now through the ideas of Higgs and dark energy, the very expansion of the universe may be coming from the energy of empty space itself. I don't think anybody would have thought that space would have this kind of rich and profound impact on the nature of reality. But as far as we've come, the journey that began with Isaac Newton's picture of space as something like a stage is not yet finished. As we examine the fabric of the cosmos ever more closely, we may well find far more surprises than anyone ever imagined. Take me, for example. I seem real enough, don't I? Well, yes. But surprising new clues are emerging that everything, you and I and even space itself, may actually be a kind of hologram. That is, everything we see and experience, everything we call our familiar three-dimensional reality, may be a projection of information that's stored on a thin, distant, two-dimensional surface. Sort of the way the information for this hologram is stored on this thin piece of plastic. Now, holograms are something we're all familiar with, from the security symbol you find on most credit cards. But the universe is a hologram? That's one of the most drastic revisions to our picture of space and reality ever proposed. And the evidence for it comes from some of the strangest realms of space, black holes.
This is a real disconnect, and it's very hard to get your head around. Modern ideas coming from black holes tell us that reality is two-dimensional, that the three-dimensional world, the full-bodied three-dimensional world, is a kind of image of a hologram on the boundary of the region of space.
This is a very strange thing. When I was a younger physicist, I would have thought any physicist who said that was absolutely crazy.
Is the three-dimensional world an illusion in the same sense that a hologram is an illusion? Perhaps. I'm inclined to think yes, that the three-dimensional world is a kind of illusion.
This idea is so new that physicists are still struggling to understand it. But if it's right, just as Newton and Einstein completely changed our picture of space, we may be on the verge of an even more dramatic revolution. For something that's such a vital part of our everyday lives, space remains kind of like a familiar stranger. It's all around us, but we're still far from having unmasked its true identity. That may take 100 years, it may take 1,000 years, or it may happen tomorrow. But when we solve that mystery, we'll take a giant step toward fully understanding the fabric of the cosmos.